In this video, I want to show that this infinite series with 2 over 4n squared minus 1, this infinite series converges to 1. So this infinite series, this is called a telescoping series. And so the first thing we want to do is go ahead and decompose use what's called partial fraction decomposition to decompose the expression 2 over 4n squared minus 1. So 4n squared minus 1 is the same as 2n plus 1 times 2n minus 1. And the equivalent expression is 2 over 2x plus 1 times 2x minus 1. And what we want to do is decompose this expression right here. So this can be rewritten as some constant a dividing by 2x plus 1 plus some constant b dividing by 2x minus 1. And now we want to combine these two expressions right here so we can cross multiply. So it will be constant a times 2x minus 1 plus constant b times 2x plus 1 dividing by these two, the product of 2x plus 1 and 2x minus 1. So from here we have 2 is equal to constant a times 2x minus 1 plus constant b times 2x plus 1. And this equation right here, this is true for all x. And so what we want to do is pick an x such that this factor right here would be equal to 0. So for example, we can let x be 1 half, because 2 times a half is 1, 1 minus 1 is 0. So in the place of x, we have 1 half and 1 half. 2 times a half is 1, 1 minus 1 is 0, so this part will be 0. And then 2 times a half is 1 plus 1 is 2, so we get 2 is equal to 2b, or b is equal to 1. So similarly, we want to pick something that would make this factor 0, so we can let x be negative 1 half. So in the place of x, we have negative 1 half. 2 times negative 1 half is negative 1, so we get negative 2a. 2 times negative 1 half is negative 1. Negative 1 plus 1 is 0. So we end up with a is negative 1. So the expression 2 over 2x plus 1 times 2x minus 1, it can be rewritten as negative 1, since a is negative 1, dividing by 2x plus 1, and then plus 1 dividing by 2x minus 1. And then we can rewrite this as 1 over 2x minus 1, and then minus 1 over 2x plus 1. So for the original series, we can rewrite it as the infinite series, with 1 over 2n minus 1 minus 1 over 2n plus 1. These are called partial sums. So this is the sum of the first 10 terms, which is 0.95238. This is the sum of the first 100 terms, which is 0.995. This is the sum of the first 1,000 terms, which is 0.9995. Here's the sum of the first 10,000 terms, which is 0.99995. And here's the sum of the first 100,000 terms, which is 0.999995. So once again, these are called partial sums. And so we can see that as n gets larger and larger and larger, the sequence of partial sums is approaching 1. And now let's find the sum of the first k terms. So this is the sum. These are the first 7 terms. This is the kth term. So in the place of n, we just have k. And then the term before the kth term, in the place of n, we have k minus 1. And then the term before that, in the place of n, we have k minus 2, k minus 3, k minus 4, k minus 5. And then simplify, we end up with this. And now we can see that minus 1/3 and 1/3, these were cancelled out, and these will drop out. And then eventually this one will drop out also. And then we can see here that these 2 terms right here will drop out. And then eventually this one will drop out also. And so what's left is just 1 minus 1 over 2k plus 1. So this is the sum of the first k terms. This is the original infinite series. And this is the sum of the first k terms. And now if we allow k to run to infinity, then we get the entire infinite series. So the infinite series is the same as the limit of s of k as k approaches infinity. But s of k is 1 minus 1 over 2k plus 1. As k approaches infinity, this term right here approaches 0. 1 minus 0, we just get 1. And so we say that this original series, the series with the 2 over 4n squared minus 1, converges to 1. And that's the end of the video.